Hello there, dear viewers. My name is Richard from JC1, and today I'm gonna be teaching Secondary 1 Math. Alright, before we begin, I just want to say that there's nothing to fear about math because all you gotta do is be bold, be brave, and above all, you have to be. Alright, so welcome. In today's lesson on math, I'm going to be elaborating on numbers and operations. So, today we're going to dive deep into integers, fractions, decimals, percentages, and ratios. Alright, first and foremost, what are integers? Well, basically, integers are pretty much any number without fractions or decimals. So these include positive numbers, e.g., 3, 8, or 100, negative numbers, e.g., negative 1, negative 20, or just plain 0. Integers are used in everyday life to describe temperatures, elevations, profits, and losses, and so on and so forth. All right, next, operations with integers. Operations include addition, subtraction, multiplication, and division. So when adding or subtracting integers, pay attention to the signs. Multiplying or dividing two numbers with the same sign gives a positive result. With different signs, the result is negative. So here are some examples. So we have negative 3 plus 5, so that equals to 2. Negative 4 times with negative 2 is positive 8. Negative 6 divided by positive 2 is negative 3. Alright, so what are fractions? Fractions represent a part of a whole. A fraction has two parts: the numerator, which is the top number, and the denominator, which is the bottom number. So, for example, 3 over 4 means 3 out of 4 equal parts. Fractions are used in measuring quantities, such as cooking, sharing, and more. Alright, operations with fractions. When working with fractions, addition slash subtraction requires like denominators. Multiplication is straightforward. You multiply the top and the bottom. Division involves flipping the second fraction, which is the reciprocal, and multiplying. And remember, always simplify fractions if possible. Alright, moving on, we're going to be discussing about decimals. So, what are decimals? You see, dear viewers, decimals are another way to represent parts of a whole. So basically, they're based on powers of 10, tenths, hundredths, thousandths, etc. So, for example, zero point 0.5 equals 5 out of 10, and 0.75 equals 3 out of 4. Decimals are commonly used in money, measurements, and scientific data. Alright, moving on, we will be converting fractions and decimals. To convert fraction to decimal, we must divide the numerator by the denominator. So 1 over 4 is 0.25. To convert a decimal to a fraction, we just write it as a fraction with a power of 10 and simplify. So 0.6 equals to 6 out of 10, which equals to 3 out of 5. Understanding both forms is essential for flexibility in problem solving. All right, moving on, we have adding and subtracting decimals. So we have to line up the decimal points and we have to fill in zeros if needed to match that decimal into its proper place. Then we just, add or subtract as usual. So for example, 1.25 plus with 0.7, we get 1.95 because the 7 is added to the 2. Therefore, we get a 9. Hence, we get a final result of 1.95. And for the next example, we have 2.3 minus 1.05, which results in 1.25. This is because the 2 minuses with the 1, and then the 3 minuses with that second point, and we will get a 0.25 as the final result because 3 minus with, you can think of that 05 as of like 3 minus 30 minus 05 basically, so 30 minus 5, so therefore we get 1.25. All right, next up we have multiplying and dividing decimals. All right, multiplication. So we ignore the decimal points at first. Then we count the total decimal places in both numbers to place the decimal in the product. For division, move the decimal in the divisor to make it a whole number. Then we move the decimal in the dividend the, the same number of places. All right. Moving on, we will now be going to understanding percentages. You see, percent means per hundred. It's a very common way of expressing parts of a whole as out of 100. So, for example, 60% equals 60 out of 100, which equals to zero point 0.6. Or you can think of it as a simplification as zero point 0.6, and you can simplify it even further into 3 out of 5. So percentages are most commonly used in sales, data, and comparisons. All right, that's enough said and done for percentages. Moving on, conversions. All right, so we'll be learning to convert percent to fraction uh, and to decimal, and you can convert them back and forth basically. All right, to convert between forms. All right, first, percent to a decimal. You see, in order to achieve this, we have to divide by 100. Therefore, 75% equals 0.75. This is because 75 divided by 100 equals to 0.75. All right, moving on to decimal to percent, we have to do the opposite, which is multiply. So we have to multiply by 100. So zero point 0.2 equals to 20%. This is because zero point 0.2 multiplied with 100 results in 20%. And to convert a percent to a fraction, we have to just write it over 100 and simplify. So for example, 25% equals to 25 over 100. And you can simplify this even further into 1 over 4. This is because if you write 25 over 100 in a calculator, it will result in 1 over 4. All right, moving on. Finding percentage of a number. So we have to find x percent of a number. To put simply, we have to convert the percentage to a decimal and then multiply. For example, 20% of 150 is basically zero point 0.2 multiplied with 150, which results in 30. So why is this important? Well, you see, it's useful in real life situations like discounts, tax, and population growth. And I think that's all said and done for percentages of a number. So let's move on. All right, ratios. So, what are ratios? You see, ratios compare two different quantities, and there's a few forms you can write an actual ratio. So, for instance, you can write them as A colon B or A to B, or the most common, well, one of the most common ways is just A divided by B. So, for example, if a recipe calls for 2 cups of flour and 1 cup of sugar, the ratio is 2 to 1. Ratios are used in recipes, maps, scale models, and pretty much so much more. And yeah, that's a pretty straightforward understanding of what a ratio actually is. So let's move on to what we're gonna discuss for this last thing. All right, simplifying and using ratios. To simplify a ratio, we must divide both parts by the greatest common factor. So we have to use ratios to find equivalent values. So, for example, if the ratio of boys to girls is 3 to 2 and there are 12 boys, how many girls? Well, in order for us to solve this problem, we basically have to flip the ratio around. So instead of it being 3 to 2, we'll basically take it as 2 over 3. And you might be wondering, what do we do with this 2 out of 3? Well, dear viewers, we're gonna multiply it. And what are we gonna multiply it with? We're gonna multiply it with the thing that we need to find. So, we have the ratio, and we know that there are 12 boys. So basically, 2 over 3, we just simply multiply it with 12, and we have found that the answer is 8. Yeah, that's because 2 out of 3 out of 12 is indeed 8. So from this, you can see that there were uh, 8 out of the problem, basically. Okay, dear viewers, so now is the time for uh, learning checkpoints slash summary. So today we have covered very key fundamental concepts in math, particularly in numbers and operations. So what we've covered today are integers and their rules, fraction structure and operations, decimals and how to work with them, percentages and real life application, ratios and simplification, and basically understanding these lays the foundation for higher math, such as calculus and all of that other stuff. So thank you, dear viewers, for watching my video, and keep on learning.
Looking in your eyes, I see a paradise. This world that I found is too good to be true. Standing here beside you, want so much to give you this love in my heart that I'm feeling for you.
Let 'em say we're crazy. I don't care about that. Put your hand in my hand, baby. Don't ever look back. Let the world around us just fall apart. Baby, we can make it if we're heart to heart. And we can build this dream together, standing strong forever. Nothing's gonna stop us now. And if this world runs out of lovers, we'll still have each other. Nothing's gonna stop us. Nothing's gonna stop us now.
I'm so glad I found you. I'm not gonna lose you. Whatever it takes, I will stay here with you. Take it to the good times, see it through the bad times. Whatever it takes is what I'm gonna do.
Let 'em say we're crazy.